Hello everybody, welcome back on my channel, How to Neuro. Before starting, I really would like to thank you so much for the amazing support I've received. I absolutely didn't expect, and I'm so happy to be here again with you with this new video. For this very first video, I decided to talk to you about a topic that I'm so interested into, which is the stress. So actually stress is, in everyday languages, we use the word stress to refer to a feeling of tiredness or general unhappiness or a feeling of being overwhelmed by the everyday, circumstances. But the word stress has a very important scientific explanation and also an important biological function. Of course, guys, if you like this type of content, if you're interested in this type of content, guys, please subscribe to the channel, leave a feedback, leave a like to the video. I really appreciate your feedback, just to also understand which one are the topics you're interested in too, so we can cover them, together. Okay, so let's begin. Let's begin with a little bit of history. The medical explanation of stress has been formulated for the first time by Selye. He was born in the Austro-Hungarian Empire in 1907, son of a surgeon, which he had an amazing relationship with. And after his doctoral degree, he moved to the US at the Johns Hopkins University, and after that to the McGill University in Montreal, Canada. Here, he noticed that even though people were suffering from different conditions, all of them were united by not specific signs of illness, like for example, being tired, losing weight, loss of appetite. In the first place, he called these conditions like general syndrome of just being sick, which is kind of funny because it's like you don't know how to call something new, just being sick. Going further on animal experiments, he noticed that actually not only these conditions were reproduced, but still he found out also other biological markers like enlargement of the adrenal glands, deterioration of the thymus, and often also ulcers at the gastrointestinal tract. In the end, he smartly linked these conditions, these signs of illness, to the activity of the HPA axis. Okay, don't panic, we go through it together. So HPA axis stands for hypothalamus, pituitary gland, adrenal gland axis. Let's go step by step, okay? H, hypothalamus. The hypothalamus is a region within our inner brain, like really deep in our brain, and it needs for our basic biological needs like body temperature regulation, circadian rhythm, hormone production. Specific nuclei within this region release an hormone called corticotropin releasing hormone, CRH. P stands for pituitary gland, which is a small protrusion of the hypothalamus that sends the release of CRH and in turn release what is called ACTH, Adrenocorticotropic hormone. This last hormone goes inside our bloodstream and reaches the last part of the axis, which is the adrenal glands. These glands are on the top of our kidneys. They sense ACTH and in turn they produce cortisol. The cortisol itself will be the last point of this axis because in turn the cortisol goes back to the very first stop of the axis and with a process known as negative feedback, it turns down the activation of the HPA axis. The cortisol is actually the most important glucocorticoids that we are able to produce, and it's roughly the main responsible of our biological interpretation of stress. With this, I'm not saying that cortisol is a bad thing. Absolutely it's not. It's super useful. Our body needs it. And it helps us with a lot of biological functions like energy production, because it's able to increase the glucose levels in our bloodstream and several other functions. The problem with the cortisol, it's not the cortisol itself, but is the time of exposure to the cortisol and the amount cortisol produced. Generally, with very few exceptions, we can say that all the stressful situation in the life leads to our HPA axis to produce more cortisol. And this helps us somehow to cope with the stress and solve the problem. This straight relation between external threat and production of cortisol is called acute stress reaction, because it's just an acute episode of cortisol production that is necessary for our body to face the threat and solve the problem. And it is basically necessary and also beneficial for our body. But if the HPA axis stay active for a longer period of time and the production of cortisol doesn't stop, this leads to a chronic stress reaction. And this chronic stress reaction is nowadays known to be at the basis of lots of medical conditions and diseases. Because this chronic exposure will lead to a rearrangement of the equilibrium of our body, usually in a pathological conditions. But maybe we will discuss this in another video, okay? For you guys, I've selected some scientific papers, reviews that could be useful for you to understand what's going on in our brain when we are facing high level of stress. I will leave everything down in the description, so if you want to check by yourself, feel free to go down into the description and check wherever you want. These reviews are from Dr. Bruce McEwen from the Rockefeller University. He unfortunately passed away 2 years ago, but his research has been of huge impact into this field. Okay, so let's start from the hippocampus, for example. The hippocampus, guys, trust me, is one of the most studied regions in the brain because it has several features that are not present in all the brain regions. And it is basically a brain region highly fundamental for episodic memory, spatial memory, as well also for mood regulation. It has been shown that the hippocampus exposed to a high level of cortisol and stress, a specific part of the neurons inside the hippocampus, which are called dendrites, that are regions necessary for receiving messages by other neurons, these regions of neurons become less prominent and also less enough. The opposite, for example, happens in the amygdala, which is a small animal-shaped region of the brain really close to the hippocampus, which is involved in the emotional memory this time. That's why the amygdala is also known as the center of fear. In this region, the dendrites increase in number and also in shape. Exactly the opposite of what happens in the hippocampus. Can this, for example, be an explanation why we feel so emotionally overwhelmed by stress in our life? Maybe, I don't know. The questions are still a lot, but the investigation on these fields is on fire. Guys, if you want to know more about stress, I will leave down in the description a lot of stuff for you. For example, I highly recommend to you a book written by another great scientist in this field, which is Robert Sapolsky from Standford University. This book is called Why Zebras Don't Get Ulcers, which is an amazing book. I definitely love it, and it helped me so much to understand what's going on in our body, in our brain, when we're facing stress and fearful condition. From Sapolsky, there are also lots of videos on YouTube from the Stanford University YouTube page that I will leave again down in the description. I personally saw all of them, so check them, guys. They are amazing, they're super interesting, and they can help you so much to understand what's going on in our body when we're facing something stressful. Okay, so this was an overview about the stress, guys. If you like the video, please guys subscribe to the channel, thumbs up to the video. Please give me a feedback on the comments, by email. I really would love to hear your feedback. That was all for today, guys. See you in the next video, okay?